Today I'm going to share in detail how AI infrastructure money was spent in 2025. If you're a decision maker, an account manager, solutions architect, or engineer, this is for you. 400 billion is reshaping economies. So knowing where it goes means knowing where to position yourself in 2026. If you're in AI infrastructure, you felt the ground shift in 2025. I'm talking about a fundamental reshaping of how much money is flowing into data centers, compute, power, and networking. Let me give you the numbers up front. Global spending on AI data centers alone hit 236 billion in 2025. That's up from 168 billion in 2024. And when you look at the total AI infrastructure investment, data centers, compute, networking, power, cooling, everything, Citi has forecasted hyperscaler capex at 400 billion for 2025. $400 billion in 1 year on AI infrastructure. To put that in perspective, that's more than the GDP of most countries. That's more than the entire global semiconductor industry's revenue just a few years ago. And it's not slowing down. Gartner says total AI spending, including software, services, and infrastructure, hit 1.5 trillion in 2025. That's up 50% from 2024. So today I want to break down where this money is actually going, the real allocation, because understanding the flow is key to not getting left behind as we head into 2026. And then we'll talk about what's coming next year, because the projections for 2026, well, they're even bigger. Let's start with the biggest bucket, compute hardware, GPUs and servers. This is where 40 to 50% of the money is going. We're talking 100 to 150 billion in 2025 alone. NVIDIA is still the dominant player. They've shipped 5 billion Blackwell GPUs in 2025 despite early production delays. 5 million units, and they're still sold out through the end of the year. Their second quarter of fiscal year 2026. Now, understand fiscal year 2026 is roughly February of 2025 through the end of January 2026. Revenues in Q2 was 46.7 billion, with data center revenues at 41.1 billion. That's up 56% year over year. Now, AMD is making real gains. They grabbed 20% more market share in 2025, largely because of strategic partnerships. The OpenAI deal was a big one. As I'm sure you may have heard, OpenAI is buying AMD GPUs and investing in AMD. Oracle deployed 50,000 AMD AI chips in their cloud as an alternative to NVIDIA. And AMD's MI300 series is showing 20% better total cost of ownership in some workloads compared to NVIDIA's offerings. So if you're planning deployments, you should be thinking about diversification, not just because of supply constraints, though those are real, but because the economics are starting to favor a multi-vendor strategy. Now, why is so much money flowing into compute? Simply because the demand is outpacing supply by 43%. AI servers grew 20% year over year, according to Standards AI Index. And lead times for high-end GPUs are 6 to 9 months, maybe more at this point. So if you didn't lock in your allocation months ago, you're not getting hardware this year. Maybe not even in the first half of next year. The hyperscalers are stockpiling. Microsoft capex for 2025 is 80 billion. Amazon is over 100 billion. Meta is in the 60 to 65 billion range. And a huge chunk of that is going into training clusters, which makes complete sense. Because if you're a hyperscaler, you can't afford to fall behind on AI capabilities. Your competitive position depends on it. Now, this is what's creating shortages and pressure everywhere, not just in GPU supply, in server assembly, in data center space, and even in power delivery. Which brings us to the next big bucket: power and cooling. Well, it was between 80 to 100 billion in 2025. Power and cooling are eating 30 to 40% of AI infrastructure spend. And this is not optional spending. This is the foundation that makes everything else work. Data centers globally consumed 176 terawatt hours of electricity back in 2023. And AI is pushing that number up fast. The U.S. Department of Energy is projecting that data center power consumption could hit 12% of U.S. electricity by 2028. And that's because AI data centers have a completely different power profile than traditional data centers. A traditional data center might have rack densities of 5 to 10 kilowatts, whereas an AI data center with GPUs, you're looking at 60 to 100 kilowatts per rack. Some of the newest high-density racks are pushing 120 kilowatts. And all of that power turns into heat, which means you need cooling, a lot of cooling. Water consumption for data centers globally is about 560 billion liters annually. And the International Energy Agency projects that's going to double to 1.2 trillion liters of water by 2030. We're talking about doubling water consumption in 5 years. So where's the money going? Liquid cooling systems. Vertev and Schneider Electric are the big players here, and they're raking in billions. Liquid cooling can cut energy consumption by 10 to 15% compared to traditional cooling. But it requires different infrastructure, different plumbing, different maintenance, and different expertise. And it doesn't necessarily solve the water problem. It just changes how you use it. You're still consuming massive amounts of water for heat rejection. Now here's where it gets a little more worrisome. Some regions are hitting hard limits. Texas saw a 62% spike in data center power demand in 2025, and the grid can handle it. There was blackouts, load relief warnings, etc. So now there are talks of 1.4 trillion in grid upgrades across the US by 2030 to support data center growth. So as you may glean from this, this is not a tech problem anymore. It's a utility problem. It's a policy problem, and it's a regional planning problem. If you're trying to build AI infrastructure, power availability is your first filter in your site selection process, not an afterthought. The first question, can you get power? Then, how much? How fast? And at what cost? Because if you can't get power, nothing else matters. That's why you've seen some big hyperscalers move to reopen nuclear plants, basically becoming their own power utility. Okay, next, networking and storage. Networking and storage are taking 20 to 30% of spending, about 50 to 70 billion in 2025. And this is where some of the most interesting technical shifts are happening. RoCE, which is RDMA over Converged Ethernet, has become the standard for AI data center networking. We talked about this in a previous video, but it's worth repeating. Meta's shift to RoCE-based Ethernet for their AI clusters is saving them 20 to 30% on latency compared to traditional TCP/IP. And it's not just Meta. The hyperscalers are all moving to RoCE. Arista is seeing massive growth in AI networking. NVIDIA's networking business, Spectrum switches and ConnectX NICs, is growing fast. And Broadcom is supplying the switching silicon that's powering a lot of this. The shift to 400 to 800 gigabit Ethernet is here, and it's expensive. A single high-end switch can cost hundreds of thousands of dollars. Multiply that by the number of switches you need for a large AI cluster, you're talking tens of millions of dollars just for networking. But this is needed. You can't skimp on this. Network bottlenecks kill GPU utilization. And if your GPUs are sitting idle, waiting for data, you're wasting money. Storage is the other piece. HBM, high bandwidth memory, is in short supply, and it's critical for AI accelerators. The industry spent $20 billion on HBM in 2025. There's still not enough to meet demand. And then there's the data storage itself. AI models are getting bigger. Training data sets are getting bigger. A large language model can require petabytes of training data. And you need fast storage to feed that data to the GPUs fast enough. So you need NVMe, all flash arrays. This is also contributing to the driving growth in edge cloud and hybrid architectures. About 20% of AI infrastructure budgets in 2025 went to edge deployments. Why? Because for inference workloads where you're running a trained model to generate predictions, you want to be close to the user. Low latency matters. So companies are deploying smaller, distributed AI infrastructure at the edge instead of centralizing everything in hyperscale data centers. This is changing the economics. Edge infrastructure costs more per unit of compute, but it delivers better performance, especially for latency sensitive applications. Think autonomous vehicles, real-time video analytics, interactive AI applications. For those use cases, edge makes complete sense.